All right, let's talk about Seaborn now, which is basically Matplotlib++, if you will. All right, so Seaborn is basically a visualization library that sits on top of Matplotlib, and all it does is make it a little bit prettier to look at, but it also has a bunch of different kinds of charts and graphs that we didn't have in Matplotlib. And just as an example, we'll start off again saying Matplotlib inline, meaning that we want to view all of our results as part of this notebook itself within the browser. We'll import pandas as PD, load up a fuelefficiency.csv file that I've uploaded here to my website here. And this is real data, by the way. So this is actual data that comes from the US government about the fuel efficiency of every car they have a record of for the 2019 model year in specific. So let's extract some information from that we can play with. Let's start by extracting the number of gears from that resulting data frame. And we're going to do value counts. And if you remember back from our pandas tutorial, that basically gives us back the data we need for a histogram that says how many times each unique value occurs in our data frame. So this should give us back a series that maps the gear numbers to the number of times each unique value appeared. We can then just plot that, saying that we want a bar chart. So right now we're just using Matplotlib as is, just to visualize this data. And there you have it. So you can see that 8-speed transmissions seem to be the most common one, followed by 6-speed, and we have sort of an exponential drop-off there to other more obscure values. Now let's use Seaborn. So Seaborn, in its most basic form, can just make Matplotlib look better. So all we need to do is say import Seaborn as SNS, and then we can say sns.set, and all that does is replace the default settings in Matplotlib with more visually modern-looking settings that Seaborn has given us. Matplotlib is pretty old. I mean, it goes back to Matplot, and it's kind of showing its age, quite frankly. So this gives it a more modern look and feel. So now we can do that same exact bar chart, but with the Seaborn defaults applied. You can see it's a little bit prettier. We have, more muted tones here, and it's also against this nice little graphical background here to actually let you visualize that grid a little bit better. Otherwise, pretty much the same. But it's just a little bit easier on the eyes, right? Let's dive into some more depth here. Let's take a closer look at the data that we're dealing with. So here's our raw data frame that we actually loaded up that came from the government here. And we'll just do head to take a look at the first 5 rows here as an example. So the information I've extracted are the car manufacturer, like Aston Martin or Volkswagen, the car line, which is basically the model, the engine displacement, that's how many liters the engine is, how many cylinders are in the engine, the transmission type, its city miles per gallon fuel efficiency, its highway fuel efficiency, the combined city plus highway MPG value, and the number of gears that each car has. So that's the information that we have to play with here. Now, Seaborn has some plots that Matplotlib doesn't offer at all. So for example, there's dist plot, and that's a way of actually plotting a histogram together with a smooth distribution overlaid on top of that histogram. So let's take a look at that on the comb MPG column. So here we have a histogram of how many times each value within comb MPG appears. You can see we have kind of this spike here around, the low to mid 20s, right? That seems to be kind of like the most common MPG rating for a vehicle. And we can overlay this sort of trend curve here automatically as part of dist plot. So that's something Seaborn is doing for us automatically without us even trying. So that makes it a little bit easier to visualize the bigger trends here. And you can see that's kind of helpful because we have these like weird values in between these other values. So it seems like there seems to be some sort of quantization that occurs in our data that we can smooth over a little bit with that trend line. So that's sometimes a useful way to visualize things. Another thing you can have in Seaborn is the pair plot. That's also something unique to Seaborn. And this is cool stuff because it lets you visualize plots of every possible combination of a set of attributes. So you can just look at every possible way of visualizing a set of values and try to find the ones that look interesting that might be useful to investigate more deeply. So as an example, let's classify cars by how many cylinders they have, and we'll look for relationships between how many cylinders each car has and their city MPG rating, their highway MPG rating, and their combined MPG rating. So let's just start by extracting those columns from our data frame into DF2. So we're going to use that same syntax that we introduced in our pandas tutorial to just extract these columns into a new data frame. So we now have a new set of rows here that only contain the cylinders and the MPG columns from our original data. Now watch this. If we do pair plot on that new data frame, df2, we can say that we want to focus on the cylinders as our primary thing that we want to look at, and with a given height to say that we want this to be a nice and big plot that we can visualize easily. Let that run. Here we go. So what we have here is like a grid of grids, right? So this is kind of neat. Let's scroll down a little bit so we can sort of visualize what's going on here. So you can see that we have on here every single column, and over here we have every single column as well. So if you want to plot comb MPG versus cylinders, you can look so here. If you want to plot highway MPG versus city MPG, you can look at this plot here. So you can see here that you can find interesting linear relationships between different columns here. So for example, just looking at the cylinders column here, we can see that there's a pretty clear relationship between the number of cylinders and the MPG, whether it's city, highway, or combined. So as the number of cylinders increases, we can see that that MPG tends to be dropping, but there's a really wide spread here for four-cylinder vehicles. So there's more to the story here in the world of four-cylinder vehicles. Some are really bad, some are really good. It's a really big spread there. So already we've got some useful insight there into our data. So we can also use a scatter plot in Seaborn 1.9. It's just a sort of a prettier version of the matplotlib one. Basically, you can plot individual data points across any two axes you want and see how your data is distributed across those dimensions. So let's say sns.scatterplot. We're going to say the x-axis is going to be engine displacement, y is going to be combined MPG, miles per gallon, and for the data itself, we're going to refer to our df data frame from our raw data. So this is going to pluck out those two columns and plot them against each other on a scatter plot. And there you have it. So each individual point in our data frame is being scattered onto this plot that maps that particular point's engine displacement and combined MPG value. And again, you can see there is a relationship here. So already we're getting some insights from visualizing that data. Again, the lower engine displacements tend to have a very wide spread of MPGs, but in general, the bigger the engine displacement, the worse the fuel efficiency, which shouldn't be that big of a surprise, right? Another cool thing in Seaborn is the joint plot. This lets you visualize scatter plots and histograms at the same time on each axis. So let's take a look at that same spread of engine displacement versus comb MPG, but this time we're going to do a joint plot instead of a scatter plot. Here's what it looks like. So we have the same scatter plot as before, but we have histograms overlaid on each axis. So we can see over here on this side the histogram of MPG ratings. Okay, so we can visualize that very easily and sort of say how this data all rolls up. And up here we have a histogram of the engine displacement values as well. So this makes it a lot easier to tell that the most common engine displacement is around a little bit under 2 liters, right? So that's a little bit of an easier way of like trying to figure out how many dots are in a given column here or section, because a lot of times they can overlap and that data is not really that intuitive to figure out. The histogram makes that distribution of data easier to see. Another thing Seaborn offers is LM plot, and that's just a scatter plot with a linear regression applied to it automatically. So I can say that same scatter plot, but instead of scatter plot, LM plot, gives me back this. Same exact scatter plot, but with a linear regression applied to it. And if you look really closely, you can see there's sort of a shaded area around there too that's giving you sort of your bounds on that regression. And we'll talk about linear regression in more depth later in this course, but basically we're fitting a line to the data that we have. Very simple concept. Back in matplotlib, we talked about box plots, and Seaborn has its own version of it as well. Box and whiskers plots. In this example, let's take a look at each vehicle manufacturer and visualize the miles per gallon rating across the vehicles they produce. So that's going to give us the spread of MPG ratings across all the vehicles each manufacturer offers. Okay, so we're going to do basically an individual box plot for each manufacturer showing the distribution of MPG ratings across their entire product line. Got it? All right, so there's a lot of manufacturers, so we're going to have to do a couple of things here to take advantage of what Seaborn offers. First of all, we're going to set the figure size to 15.5. That just makes it bigger so we can fit more information on the screen. We'll then define the box plot itself. We're going to say we want to plot the manufacturer on the x-axis and the combined MPG values on the y-axis, using our original data frame here as the data, df. And we're going to save that box plot into an AX variable. We will then set the tick labels on that plot to have a 45-degree rotation. That way they'll be easier to read because there's a lot of them. So the syntax here is we're going to say set x tick labels on the x tick labels that we get back from that plot with a rotation of 45 degrees. So it's basically saying I want to set the labels on the x-axis to the existing labels, leave them unchanged, but specify a rotation of 45 degrees. So let's go ahead and kick that off. The set x tick labels command put out some output here as part of its process here, but here's the chart itself. Pretty interesting. So you can see that 45 degree angle that we specified on the labels here being used there. That's a lot easier to read. And you can look at the spread of MPG values for each individual manufacturer. So pretty interesting. Volkswagen has a really wide range, for example, whereas Aston Martin is pretty tightly clustered. Volvo also pretty tight here, so interesting stuff. Also General Motors tends to be clustered here around, mid-20s or so, but they have a lot of outliers up here on the higher end as well. So it seems there's a few very efficient General Motors cars out there as well. Then we have Ferrari, obviously not very good MPG because people who drive Ferraris care more about performance than fuel efficiency, I think. So interesting insights to be gained from this box and whiskers plot here of fuel efficiency across the models for each vehicle manufacturer that we know about. Fun stuff. And hey, it's pretty too. It's again, it's modern, pleasing colors, and that's kind of what Seaborn gives you out of the box. There's also the swarm plot, which instead of boxes and whiskers, plots each individual data point, but it actually groups them together in a way that makes it easier to visualize them. So it makes more sense when you look at it. We'll just do a swarm plot on the same exact thing. So on the manufacturer name and combined MPG from our DF data frame, again, we will set the rotation to 45 degrees on the x-axis and kick it off. Only difference here is we're doing a swarm plot instead of a box plot. You can see here, instead of the box and whiskers, we're just getting this different format here where we're sort of clumping together these points here to actually represent the distribution of the data better. So each individual vehicle is being plotted to a point on this graph, but we're grouping those points together horizontally to try to reflect the distribution of those points a little bit better. So it's a way of looking at the raw data a little bit more so than in a box plot, but it's still grouped in a way that gives you the same information as a box plot, just with more refined information. So this is what we call a swarm plot. You can get the same results out of it. So again, looking more deeply into Volkswagen, you can see that they have a pretty wide spread here. There's a bunch around 30 and a bunch around 10, and nothing much in between. So kind of a curious case there. And I think that's because Volkswagen actually owns a bunch of different brands that are targeted at very different markets. So we're kind of probably seeing the consumer vehicles up here and the performance vehicles way down here would be my guess. General Motors, very tightly clustered in this range here. They are more about mass market vehicles, so they kind of want to be in that sweet spot there of things that perform reasonably well, but also perform well too. Kind of appeals to an American audience. Anyway, just another way of looking at it. One more is the count plot. Basically the same thing as a histogram, but it's for categorical data. So a histogram really is only a histogram if you're dealing with numerical values. If you're dealing with categories, though, that's called a count plot. So let's just look at an example again. Let's extract the manufacturer names and just take a look at how many cars each manufacturer makes. So we're going to do a count plot, counting up how many vehicles each manufacturer has. And again, we'll rotate them by 45 degrees so we can actually read those X labels. And there you have it. So just like a histogram, except that it's broken down by category, so there's no real inherent meaning to the actual order that these appear in. They're just counts broken down by category. That's all there is to it. That's all a count plot is. So you can see pretty clearly here that General Motors has the most number of car models available, followed closely by BMW. And, again, these are big companies that own other manufacturers. So, we're not necessarily saying that there are over 100 different BMW models on the market in 2019. Those include other brands they own as well. But, on the other end here, there's a very few number of Aston Martin models and a very low number of Rolls-Royce models, for example. So you can really see the distribution here of how many models each manufacturer produces very easily. Finally, let's take a look at a heat map. Heat maps are fun. So they're a way to plot 2D data, but where the colors represent the individual values within each cell of that table. So it makes more sense again if you just look at it. Let's make a pivot table from our original data frame to create a 2D table mapping average MPG rating for each combination of the number of cylinders and engine displacement. So let's take a look at this heat map that we got here. We're going to say pivot table on our original data frame just to extract this 2D information, basically a 2D array that maps the combined MPG for each combination of cylinders and engine displacement. So basically what we're ending up here with is kind of like a data frame, right? Where we're mapping cylinders against engine displacement with individual cells in that plot containing the MPG for each combination. And we're going to aggregate these together using mean. So we're going to say we want to look across all the different values and take the mean for each individual combination of cylinders and engine displacement. So if there's more than one car that has, say, a 4-cylinder 2.0 liter engine, we'll take the average of all those cars together to arrive at the value in that cell of that plot. Okay? So this is what that plot looks like as a heat map. Now, a lot of the data is missing because apparently there's no such thing as a 12-cylinder 1.4 liter engine. That would be crazy. But these represent all the values that we actually have data for in our data frame. And the actual color of each point corresponds to the value of that cell. So for example, here's the legend of what those colors mean. Black is somewhere around 12 mpg. So if you have a 16-cylinder 8-liter engine, that's going to have a really horrible fuel efficiency on average of just 12 mpg. Okay, so that's how you read this thing. And you can see just by looking at it that as you go up to this end of the plot, this corner here, you have low number of cylinders, low engine displacement. Those have very light colors because they're more fuel efficient. As you get down toward this corner here of lots of cylinders and lots of engine displacement, you get into worse and worse fuel efficiency. So this heat map makes it very easy to visualize how those actual MPG ratings change as a function of where they are in this plot. So that's a heat map. Alrighty, if you want to try this out on your own, here's a little bit of a challenge for you. So try to explore the relationship between the number of gears a car has and its combined MPG rating. And I want you to visualize these two dimensions of data in a bunch of different ways. Do a scatter plot, do an LM plot, do a joint plot, do a box plot, and do a swarm plot. What conclusions can you draw from that? So before you scroll down, give it a try yourself. I left you some empty spots here to actually play with and give that a shot. No peeking ahead of time, but I do have my solution down below if you want to take a look when you're done and compare your results to mine. So give that a shot. Hopefully you'll get some results, but if you do get stuck, feel free to scroll down and don't peek, but my answers are down there, okay? So have some fun with that, and I hope that makes Seaborn a little bit more real to you. Again, we're going to be using it quite a bit throughout this course. It's a very useful visualization library that is also good to look at. And there you have it.